So my name is Wenzhen Yuan. I'm currently an assistant professor at Carnegie Mellon University, the Robotics Institute. And here, I'm also the group leader of the Robot Touch group. So we have a bunch of talented people working together here to try to understand how robots can better use tactile sensing to understand and perceive and interact with the physical world. Carnegie Mellon is a great place for robotic research. We have the largest robotic institute in the United States or even in the world that covers almost all aspects of robotic research. And there's definitely lots of interest about getting robots to better understand the environment through touch. So in the areas such as manipulation or navigations or even flight robots. So there's lots of potential directions for robot doing dexterous and complicated manipulation tasks with the help of the tactile sensors like GelSight, so that they can better understand what is happening in the grippers or even on the other side, other part of the robots. And there are also some needs for the navigation robots or space detection robots, so that they want to understand some details about the objects in the environment, such as getting a finer mapping. So there are many ways tactile sensing can help robots for a more intelligent interaction with the physical world. So for example, we can tell the robot about is it touching anything, and especially during grasping, which is a very common task for robots to do. Touch sensing will help robots to understand what is in the gripper and whether the grasp is successful or not. So another thing we are looking a lot into nowadays is how tactile sensing can provide some nice perception results for the robots. From the perspective of robotics, GelSight is a breakthrough in tactile sensing, since that is providing a much finer details about the information we can get at the touch surface. So before GelSight, most tactile sensors can only detect the normal force with a spatial distribution of several millimeters level. But GelSight provides so much finer details regarding to the contact geometry and force, and we can see the details with the spatial resolution in the 20 or 30 micrometer level. So there are also lots of need for the tactile sensing for the robots in the real world. So, for example, in the factories or in the farmland or in food processing process, and there are many faculties looking into the application of robotic technologies in those fields as well. And we are also looking into using tactile sensing for robot navigation or environment perception. So we're thinking about making a mobile robot carrying a sensor like GelSight and to touch the environment so that we can get very fine details about what exactly in the environment and what's the texture of the material and whether there are some special textures on the objects in the environment. So there is an increasing need of introducing more robots in factories, because that can largely improve the efficiency and also save lots of labor force. And the core things robots need to do in manufacturing is manipulation relevant tasks. And the GelSight sensor can help robots to do those tasks with much better precision. And examples are assembly, grasping, pick and place, and also cable routing. Cable routing is challenging since the robots need to deal with deformable objects, and there's lots of uncertainties. But with the help of GelSight, the robots can get a very precise perception results regarding to the state of the cable so that they can achieve the task with much better precision.